Hello, chemists. We are going to talk about combustion today. I'll make a separate video for the mixed practice part that I happen to have in the same PowerPoint. Today, we're just going to learn about combustion. So we're on page 17 of your notes if you're following along from RHS. So what is combustion? We talked about how combustion is basically like burning. So it is specifically burning of a fuel type compound. And so that fuel is, for us, oftentimes going to be a CH compound. So we call those hydrocarbons. And that fuel is going to be mixed with oxygen gas, which we know is, again, fuel for a fire. And it is always going to produce carbon dioxide and water. So here is our carbon dioxide and here is our water. So really the only thing that's going to vary in a combustion reaction is what fuel we are talking about. Another option for what the fuel might look like is CH and O. So it can be a CH compound like we have up here in this first example, or a CHO compound like we have in the second one. But you'll notice that everything else is the same. Remember, it was plus oxygen, produces carbon dioxide and water. Same thing on the second example. It is plus oxygen, produces carbon dioxide, and the water just got pushed down to the next line. The water should be up here. The first compound, again, which is the hydrocarbon, the fuel, can be any combination of carbon, hydrogen, and sometimes oxygen. So we just have a bunch of examples down here: CH4, C2H6, C4H10, etc. And then we can have some examples that also have oxygen in them: C6H12O6, C12H22O11, C5H10O5. All of these compounds are possible fuel for combustion. And so they can be substituted into this first part of a combustion equation right there. Now, I'm going to go ahead and give you my hint for combustion reactions. It's very common that you'll get stuck on a combustion reaction. So an example of this might be right here. So we have C4H10. So if we have 4 carbons, we will put a 4 in front of the carbon dioxide on the product side. Now, carbon is 4 and 4. If we have 10 hydrogens, well, we're going to put a 5 in front of the H2O because now here highlighted in pink, I show that I have 10 hydrogens. That's perfect. But if we now look at the oxygens, which I will highlight in blue, I've got 4 times O2, that's 8 oxygens there, plus 5 times O, that's 5 oxygens here. 8 plus 5 is going to give me 13. There is not a coefficient here that I can put to make that 13 oxygens, because something times 2 to equal 13, well, it would have to be 7.5, and we're not allowed to use decimal numbers. So if we learn Miss Hammer's hint, here it is. If you get stuck, put a 2 at the very front of the equation where that big orange arrow is pointing. Put a 2 there and then continue balancing. So watch how this edits. So I'm going to switch to red. Okay, so if I put a 2 there, I now have 2 times 4 carbons. So that's, it's not 4 anymore, it's 8. So that makes me switch to an 8 right here in front of CO2. What about hydrogens? I have 2 times 10 for the hydrogen, that's 20. So instead of the 5 right here, I would need to put a 10. Well, okay, what does that mean about the oxygens on the product side now? I have 8 O2s, that's 16, plus 10 oxygens, that's 10. What's that equal? 16 plus 10 is going to be 26. So I need 26 oxygens on the reactant side. What coefficient would I put in front of O2 so that it equaled 26? That is going to be a 13, because 13 times 2 would equal 26. So hint, if you get to this point and you're like, I got an odd number there, what do I do? Miss Hammer says, go to the very beginning, put a 2 in front of it, and try again. So what this one works out to be is 2 C4H10s, 13 oxygens, 8 carbon dioxides, and 10 waters. It's pretty common. This happens quite a bit, so it's a helpful hint for when you get stuck. All right, we're going to practice some equations here. So we're going to predict the products and then balance. So first up, number 1, we have CH4 plus oxygen O2. Well, what are the products going to be? The products of combustion are always the same. Carbon dioxide, CO2, and water, which is H2O. Now we want to balance. So I'm going to balance in pink. I'm going to look at carbon first. I have 1 carbon on the reactant side. I have 1 carbon on the product side, so carbon is good to go. Carbon is 1 and 1. Next up is hydrogen. I have 4 hydrogens on the reactant side. I only have 2 hydrogens on the product side, so I need to multiply it by 2 with a coefficient out front, so that's 2 times 2, to equal 4. So my hydrogen is now 4 and 4. All right, finally, I need to look at my oxygen. Oxygen has 2 on the reactant side, as always, because that's always O2. But I'm going to highlight in blue how many oxygens do I have on the product side. So I have 2 right there. And then with the coefficient out front, I have 2 oxygens over here on the product side. So on the product side, at oxygen, I have 4. So what do I need to put in front of the oxygen O2 to make it 4? I need to put a 2 out front. So that was multiplied by 2 to make it equal 4. All right, so I have 4 and 4 oxygens. I'm going to get rid of some of my extra markings. And that is my balanced equation. You've probably done that one before if you've been balancing equations for a week or 2, but it's still good to practice as much as possible. Okay, let's do another one. C3H4 plus O2. Let's see how this turns out. So what are my products going to be for combustion? It's always CO2 plus H2O. All right, so let's look at my carbon first. Carbon starts with 3 and ends with only 1. So what do I need to multiply right here on the product side to make it equal the 3 on the other side? I need to multiply by 3. So I'm going to put in a coefficient of 3. It's going to be times 3 to make it equal 3. Carbon, good to go. Next up, hydrogen. Let's see, I'll balance hydrogen in purple. Hydrogen, I have 4 on the reactant side, and I only have 2 on the product side. So what do I need to multiply this hydrogen on the product side to make it equal the 4 over on the other side? Because it's a 2, I need to multiply by 2. So coefficient of 2 out front, that was times 2 to equal 4. Check mark, my hydrogen looks good. All right, finally, my oxygen. Because oxygen shows up in 2 places, I like to highlight it all on my screen here for you. 3 times the oxygen here. That's right there, 6 oxygens, plus a couple more over here, 2 more oxygens. So that's 8 oxygens. Okay. To make the oxygen over here on the reactant side equal 8, what do I need to put in front of it? Just a 4, because 4 times 2 would equal the 8 oxygens on the product side. So 4 there gives me 8. Everything is balanced. We're good to go. So that is my balanced combustion equation for C3H4. All right, let's try one more. We've got C2H6 plus oxygen. That's fuel plus oxygen, that's combustion. So the products are the predictable, always the same, CO2 and H2O. All right, let's look at our carbon first. Carbon has 2 to begin, but only 1 to end. So what do I need to put in front of this CO2 to make it 2 carbons like on the other side? I need to put a 2 in the front. Okay. Now that was times 2 equals 2. Carbon checks out. Next up, we have hydrogen. Hydrogen is 6 on the reactant side. Ooh, but it's only 2 on the product side. So I need to put a 3 in front of it because 2 times 3 will equal 6. Okay, so hydrogen is 6 and 6. That is balanced. Let's look at all of our oxygens now and see what we have. 2 and times 2, that's 4, plus 3 times 1. Let's do this in blue. Make it match. That's 4 oxygens plus 3 more oxygens, which is 7. So my oxygen here is 7, but on the reactant side, it's a 2. There is not a whole number that I can multiply by here to make that equal 2. Sorry, to make it equal the 7 on the other side. I can't multiply by 3.5 because decimals are not allowed as coefficients here. So I'm going to rely on Mrs. Hammer's fancy trick. It's not really fancy. I am going to put a 2 at the front of this reaction and try again. And it's going to work. It's always going to work. Okay, so I put a 2 here, and I kind of start from scratch. So carbon is 4 on the reactant side because that's 2 times 2. And so I need to put a 4 in front of the carbon dioxide so that it's 4 on both sides. Check. Hydrogen, follow along. We got 2 times 6 hydrogen, so that's 12. 12 hydrogen. So what do I need to put in front of H2 to make it equal 12? I need to put a coefficient of 6 because 6 times 2 would equal the 12. 6. That's 6 times 2 to equal 12. All right, now let's add up the oxygens again, and it's going to work this time. Oxygen, I have 4 times O2, that's 8. Plus, I have 6 times 1, that's 6 more. So 8 plus 6 is 14. 14 oxygens on the product side. What can I put in front of O2 to make it equal 14? I can put a 7 there. So there we go. So let me erase some of my extra notes here. And we now have the balanced combustion reaction of C2H6. All right, that is pretty much it. That's how combustion is going to work. We've got our answers here, and that's as far as we're going to go in this video. That's how to balance combustion. If you watch out for my next video, we are going to practice how to look at mixed up reactions. We don't necessarily know if they're single, double, replacement, or synthesis, or decomposition, or combustion, and we're going to talk about how to identify them and then write the balanced equation. So thanks for watching.